Hey everyone, here's another example from section 3.1, another solving application problem. This one is a little different than the other ones. It starts with a stone is thrown downward with a velocity of 44 feet per second, 30 miles per hour, from a bridge that is 120 feet above a river. And then they show the illustration here, so they're throwing the stone downwards, so he throws it straight downwards, not up and then down, but just straight down. It says write a formula S of t that models the height of the stone after t seconds. Well, to write this formula, we need to remember this formula. I believe they give it to you in the book, but h of t equals negative 16 t squared plus v, or velocity initial, times t plus height initial. So this is a formula that it's kind of just a standard formula equation for the height of an object being thrown after a certain amount of time. So we're going to use this to basically write our equation. So the first thing we're going to do is we're going to write down what our initial velocity was. Well, our initial velocity was 44 feet per second. And then our initial height, HO, is 120 feet. And now we're going to take these and we're going to plug them in here. So we're going to get h of t equals negative 16 t squared. Now, one thing we have to watch here is it depends on if our velocity is traveling upwards or downwards, whether or not it's plus or minus. So if you remember back to the problem, it says downward with a velocity of 44. Well, downward is going to mean negative. Upward is going to mean positive. So downward, we're going to say minus 44 times the time. But our initial height then is 120 feet. So this is our equation for part A. So this would be the answer to part A. But for part B, it wants to know, does the stone hit the water within the first 3 seconds? Explain. Well, let's check it. If we get a negative number when we plug in 3 here for t, obviously it already hit the water because it's below water now. If we get a positive number, then it's still got a little ways to go. So let's do h of 3 equals negative 16, 3 squared, minus 44 times 3, plus 120. So if I do 3 squared, that's actually negative 16 times 9, minus, let's see, that'd be a 132 plus 120. Now, I can kind of just stop right here. Negative 132 plus 120 is negative. This is going to be negative. Obviously, the stone, the height of the stone is going to be a negative height. So, height of stone is negative. What does that mean? Well, if the height of the stone is negative, then it must mean that it hit the water already. So, yes, the stone hit within 3 seconds. And that's how you solve that problem.